and scientists have confirmed that the Arctic Ocean has just passed one of those moments. And here's the part that really got me. It didn't happen this year. It didn't happen last year. It didn't happen a decade ago. It happened in 2009. 2009, what a year. Avatar fully took over James Cameron's brain. Obama took office and disgusted the world with his tan suits. Susan Boyle dreamed a dream and Michael Jackson stopped dreaming. I finished high school and looked terrible. And amidst all of this, deep down in the Arctic Ocean, 2009 marked the beginning of a deadly cycle of events that is now threatening to spread across the world. And it's just not getting the attention it deserves. So let's get into it. What's happening? Why is it happening? How bad could things get for the Arctic? And how could it affect the rest of the world? Let's start with something you probably learned a bit about in school and then forgot straight away. Nitrate. You see, the Earth is a seriously nitrogen-obsessed planet. 78% of the atmosphere and the air that we breathe is nitrogen. But although we're constantly covered in nitrogen like Winnie the Pooh in a honey factory, there's only a few forms of nitrogen which are easily usable by life. There's ammonia, there's nitrite, and there's nitrate. Nitrate, amongst all the many amazing things that it does, it allows phytoplankton, those tiny microscopic plants that really allow the ocean to thrive, it's what helps them to metabolize. You see, phytoplankton, for all their ineptitude in the face of SpongeBob, they are the essential building block for virtually all ocean life. Think of the entire Arctic food web as a Jenga tower. Nitrate is the bottom row. Now here's the detail that really stopped me cold when I was reading this study. For years, for decades, one of the prevailing theories about the future of the Arctic was that, okay, sea ice is disappearing, but a possible benefit of sea ice disappearing would be more plankton, which kind of makes sense, right? There was this idea, sea ice loss equals greater primary production. That was a simple formula. The Arctic is greening all over. More sunlight and more warmth means more favourable conditions for plant life. But it turned out that was all wrong. A team of researchers from the University of Edinburgh have discovered, after analysing over 20 years of ocean sampling data, that this relationship between sea ice and plankton growth, it hasn't just weakened, it's completely reversed. Yes, more sunlight is reaching the Arctic Ocean. Like an Irish person stepping out into the sun after 11 months of darkness, the Arctic isn't prepared. The sun is destroying the conditions it needs to live. The Arctic Ocean is actually the shallowest ocean on Earth. After all, it only dates other oceans that are over 6,000 feet tall and work in pirate finance. And as Arctic sea ice disappears, it's exposing vast stretches of shallow continental shelf. These shelves cover nearly 50% of the entire Arctic Ocean. Half. An enormous area that was for thousands of years shielded from direct sunlight by nearly permanent ice cover. Now sunlight is hitting the shallow water, and initially, life seems to accelerate, and that's what was giving us those theories before. It's what comes next that's the problem. The algae goes through its normal life cycle and it dies. It sinks to the bottom of the ocean, where it starts to decompose. The microorganisms that are decomposing this algae, they have to do their own bodily functions as well, and while they're in the sediment doing this decomposition, they're extracting oxygen from the sediment. Now this is the normal life cycle of algae around the world. So you'd think it would be okay, it's just the same thing happening, that it happens in the Mediterranean as it's happening in the Arctic. What's the problem? But it turns out the Arctic is different. It's why I love it so much. All oceans on Earth are currently losing oxygen as a result of climate change, which just that fact alone is fucking terrifying. But the Arctic Ocean is losing oxygen at a rate of about 6 times faster than all the other oceans. In these oxygen poor conditions, marine microbes, well, they have to take in something other than oxygen to survive. They go to their plan B. Their backup is nitrate. In their process of consuming nitrates, what they expel after that is just pure nitrogen gas. Nitrogen gas which isn't usable by other marine life. It just, little bubbles appear, float to the top of the ocean, escape into the atmosphere, and it just joins the rest of the nitrogen gas in the air. It's not a fossil fuel, it's not anything like that, it's not contributing to global warming the same way that methane gas does. But it's its own serious problem, because in doing this, nitrate, a key vital resource for phytoplankton for so much life, turns into gas, floats to the top of the water, leaves the ocean. Now this process, it's not anything brand new. It's called benthic denitrification. It has been happening for millions of years. It is a natural process. The problem is the scale, the sheer scale we're now seeing it. The team behind the study was tracking this process through the Fram Strait, and their studies showed that once we hit 2009, 500 Days of Summer was released, which ended up kind of being quite prophetic because it turned out that was the year we were going to stop feeling cold again, and nitrate levels moving through the Arctic started falling, and then falling, and then falling some more. Nitrate is leaving the Arctic Ocean, and it seems for good. What is the problem with this? I mean, there's other forms of usable nitrogen. Like I said, you've got ammonia and nitrate, and that's because the particular kind of phytoplankton we're talking about, which supports all this great life, it's quite large phytoplankton. There's other forms of phytoplankton that can survive on other forms of nitrogen, but they're much smaller, much less nutrient rich, much less satisfying, probably taste worse as well. An ecosystem-wide energy drain that cascades across land, across sea, across ice, across air, until every single living thing now has to contend with this nutrient-poor world in which death is just around every corner. And it turns out that the problems don't just stop there. Plankton don't just feed the food chain. They're a critical carbon sink. They absorb CO2, they absorb greenhouse gases from the atmosphere. And again, that was one of those theories about, well, things might end up being okay in the future because sea ice melts, but it's going to lead to more plankton, so the Arctic Ocean's actually going to end up being a better carbon sink. All these theories that we desperately cling to, scientists, climate scientists, we desperately cling to good news like an astronomer peering through a telescope, commenting on how nice the moon looks as the meteor shower batters everything around him. But instead, we're going to see fewer plankton, which means a worse carbon sink. A weakened carbon sink means more carbon dioxide in the atmosphere. More carbon dioxide in the atmosphere means more warming. More warming means more ice loss. More ice loss means a more exposed continental shelf. A more exposed continental shelf means more denitrification. In every sense of the word, this is a negative feedback loop. And it's especially bad because the two areas which are most impacting this own negative spiral, they are stuck in their own negative spirals. Sea ice and sunlight. And this means that nitrate and the entire Arctic food web is stuck in a 3-layer deep negative death spiral like a Tres Leches cake that's been left out in the sun for 6 weeks. Professor Rajaganashram of the University of Edinburgh, who's been studying this topic for over 20 years, had this to say. The changes we report suggest the Arctic Ocean ecosystem passed a tipping point around 2009. How this change cascades through the food chain needs to be closely monitored, as this has profound implications for us, including on commercial fishing in the North Atlantic Ocean. Commercial fishing, the North Atlantic. For many of us, this isn't far away. That's the waters of the UK, of Canada, of parts of the US, of Iceland, of Norway, of so many other countries. And I do need to put this into some additional context because this isn't happening in isolation. When we talk about tipping points, it's really easy to get lost in the doom scroll of it all. You've got things like my beloved movie, The Day After Tomorrow, which covers basically a semi-realistic tipping point. It covers the collapse of the Amok, but the real story isn't this single Hollywood-style explosion that you can point to and say, yes, that's the thing, and that's the thing we need to solve. It's thousands of small, interconnected, but seemingly not connected events. I could spend the next 2 weeks detailing all the interconnected climate events happening in the Arctic and how they lead into this specific one as well. But just to name a few, you've got Siberian permafrost melt, you've got the boreal forests that ring the Arctic that are stuck in this spiral of wildfires, not being able to recover sufficiently, leading to more wildfires and so on and so on. All these death spirals peppered across the Arctic, while the rest of the world was arguing if climate change was even real, and if it is, should we even do anything about it. These critical tipping points for all life on Earth are passing, are breaking, and I don't know what we can get back. Getting back to the study, the truth is, in regards to how this affects the rest of the world, that is something that we can't say for sure right now. I definitely have my thoughts on that. I have my worries and concerns, but more research is needed. But the direction of travel for the Arctic Ocean is not ambiguous anymore. We cannot say at all anymore that we don't know, it might end up good, it might end up bad. We can say for sure right now, it's ending up bad. And we just have to figure out how bad, if there's anything we can do to help it. Somewhere in the Fram Strait right now, cold water is moving south. What once carried the promise of breathtaking beauty, of a planet that can support such a vast array of life that we're discovering new life forms every single day, now carries the chemical signature of death and a changed Arctic. For millennia, it was protected by the ice, by the cold, by the sheer inaccessibility, by the presence of polar bears. Most of the world never thought to look too closely. First we explored, then we inhabited, and then we discovered the breathtaking beauty of the north. None of us will have thought that the actions we took further south will have such a profound impact on the far north. But now the ice is retreating. The ocean, the land beneath the ocean, it's visible. The consequences of our actions is laid bare for us all to see. We can't take our eyes away. We can't stop looking at what we've done. Only then, only if we face up to it, can we do our best to stop it from dying. Thank you so much for watching this video. I like to think I'm getting good at the storytelling side of things, but I am very aware I'm not so good at the algorithm side of things, so it is such a huge help for me if anyone can like these videos, can leave comments, can share them to people that they think would also like them, and of course to subscribe to the channel for more videos about all sorts of things. I know lately there's been a lot of depressing climate news. I promise I do have some things in the pipeline which are a bit more uplifting, I promise. Thank you for spending some of your time with me today, and what do you think? What do you think the future of the Arctic looks like? To what degree can we salvage the future of the Arctic? Or in what way will it change? In what way will the Arctic maybe stabilize itself in a completely different manner? As always, stay warm, stay safe, and I'll see you next time.